To save a little time, I've already given you the factored form of this rational function right here. So we're going to get started with that, and I want to start with x-intercepts and y-intercepts. Those are pretty easy. X-intercepts come from factors that are on top of the fraction, okay? And they can't be on the bottom of the fraction, they're only on the top. And you see we have one of those right here, this 2x minus 1. So the way I turn that into an x-intercept is pretty easy. You just set the factor equal to 0, and then you solve it. So that gives you x equals 1/2. And that should be written as an x-intercept, which is 1/2 comma 0. So that would be my answer right here. Okay, that's the x-intercept. The y-intercept is not found in the equation easily. You have to change something in the equation. You might remember this. You say f of 0. In other words, you change x to 0, and then you evaluate the equation. So I'm going to focus on this part of the equation over here when I plug in 0. It's a little easier that way. And this becomes 2 times 0 squared plus 3 times 0 minus 2 divided by 3 times 0 plus 4. And you see all these zeros, you can just knock those right out. They don't matter, they're just 0. So what you get here is negative 1/2 once you simplify it. And that turns into an intercept, which is written as 0 comma negative 1/2. So I'm going to put that right here. And while I'm doing this, I want to mention the fact that the x-intercept is 1/2 and the y-intercept is negative 1/2. They may look similar, but that's just a pure coincidence. That's not a pattern. Okay, moving on. There's something in here called a hole, which we need to talk about, how to find holes in a function. And those are in the equation. They're factors that are on top and on bottom at the same time. Now, if you notice in this equation right here, let me clean some of this stuff up that I don't need anymore. If you notice in that equation, there's some stuff that's, there's no factor on top that's also on bottom. Okay, so the very quick answer, what I'm trying to get at here, the very quick answer is that this is DNE. Now, that's not going to help you too much if you do have a little factor that's repeated. So I want to go on a short side quest here and say, what if our f of x was something like the following? What if it was 2x minus 1 times x plus 2 divided by x plus 2? Okay, so what if there was a repeat factor on the bottom, where now you see I intentionally made a hole appear in this function? What you would do is you would say, okay, I'm going to take that x value, and in this case, you find the x value by saying x plus 2 equals 0. That means x equals negative 2. And then you plug that back in, and you say f of negative 2, which would be 2 times negative 2 minus 1. That's the first factor. And see this second factor of negative 2 plus 2? That just crosses out. This is why holes are called removable discontinuities. So what would you get as your result? You would get negative 4 minus 1, which is negative 5. So the hole would be located at negative 2 comma negative 5. That's how you find the location of it. You just evaluate the x, and then you plug it right back in. Okay. In that case, while we're on this side quest, my vertical asymptote would be DNE, because there would be no factor on the bottom alone. It would only be the hole. But that's not the case. So we're going to move on past this, and we're going to say, okay, my vertical asymptote is simply, well, let's see, what is that one? For this case, I'm going to look at the denominator and say, what factor do I have there that's by itself and is not repeated on the top? It's, in this one, 3x plus 4. So I'm going to say 3x plus 4 equals 0. And that means x equals negative 4/3. Okay, so negative 4/3. Now, this thing is top heavy, this function. And the reason I'm mentioning it as top heavy is, look here. See that x squared and this x? That's a higher exponent on top. So that means horizontal asymptote is DNE because it's top heavy. And the last thing we have to do is probably the hardest. We have to do long division to discover the oblique asymptote. So I'll try to move through this part as quickly as I can. We have 2x squared plus 3x minus 2, and we have 3x plus 4. That's the division. So when you do that division, watch out, because this one has fractions in it, and they often do. This is going to be 2x squared on the bottom plus 8/3 x. Now that's ugly. I'll admit that. And when you do the subtraction, you have to be really careful about how these things work out here. 3 minus 8/3, that's going to be a positive 1/3 x. Carry down your minus 2, and then you do division again, which is going to give you 1/9. Not pretty, but that is allowed for things like oblique asymptotes. Sometimes they just look like that.